So, welcome back. We were discussing, after considering spending a lot of time in different type of combinations and options, we have just started. In the last slide or the last class, we just discussed very briefly about the binomial tree. So, what is the main focus is to understand how the stock prices in general, I am not going to go into details, that how the prices fluctuate and how different concepts in mathematics and statistics can be utilized in order to find out the overall pricing of an option in a very simple manner. So, let us consider a binomial tree and we consider the T diagram as shown. So, what is the diagram? Rather than going back to the slide, I will just draw it. So, you get price 20 here, it increases to 22, it falls to 18, and these P's and 1 minus P's are the probabilities. Again I am mentioning P is the probability, not the price of the put option. So, let us consider the example with the tree diagram illustrated in the previous slide. Let the portfolio consist of what? What are these? A long position in delta number of shares of stocks and a short position in one call option. So, we will find the value of this delta number, which will make the portfolio riskless. What we mean by riskless, that will become evident to you within 1 or 2 minutes. Now, for the upward price movement, the value of the portfolio would be what? It would be, if you had delta number of shares, so the actual value would be 22 into delta. So, this is the number of shares which you had multiplied the price. And where is this 1 coming from? 1 is basically the one call option which you had. So, you are basically having a call option, which means what? Call means you are going to call back. So, that means the total amount of money would be going out of pocket, and the price of this share which you had initially would be positive. Hence, we are basically utilizing the fact that you are 22 into delta, the total quantum of the spot number, and this minus 1 is basically the one call option. Now, for a downward price movement, the value of the portfolio would now be, because if the prices, if you think are on downward trend, obviously you would not exercise it. The overall value now remains as 18, because that is the price multiplied by number of stocks which you have, which is delta. And why this minus 1 is not coming here is that because you would not be exercising that call option. So, if you consider the overall value of that option, and if you consider that you are neither going to make a loss nor going to make a profit, because it is going to be such a position that you are going to even out. So, the even out position would be what? You in one instant, when is the price increase, would be 22 into delta minus the 1 coming because the call option has been exercised, and in the downward trend it would be 18 into delta. So, if they are of the same value, what it is? The overall expected value would be same, you equate the expected value and you find the delta is to be 0.25, which means that if the price is 20 as of today, and if you are thinking the prices would be increasing with probability P to 22 and is going to decrease by probability 1 minus P to 18, then the total amount of stocks which you would buy in order to basically make an even out position would be 0.25, which is 1/4 of a stock. So, consider now, let us consider symbols in much more explicit detail. Considering the stock price can either move up and down in one step. So, now the question is that what is that one step? So, let me draw a diagram explicitly. Consider these are grids, and the grids have also horizontal lines, and consider this point is somewhere here. So, now if it is a two step process, it will either move up or go down. So, this point which you had, which is A1, is this A1, the point which you had B1 is this B1. That means, this diagram which you have is for this plane. Next, what you will see? Again in the next instant, this price would increase and decrease, increase with probability P, if it remains same, decrease with probability 1 minus P, it remains the same. So, this upward trend would happen in such a way that will increase to this, which is A2, decrease to this, or B1 can increase to this, decrease to this. So, what you have that depending on one step simple binomial tree, you have been able to formulate that in the second stage the prices are of 3 values. Consider them as A2, A3 and A4. So, in this case B1, which was the price which is basically given here, would increase by probability P, would decrease by probability 1 minus P. Similarly, A1 would increase by probability P to A2 and decrease by probability 1 minus P to A3. So, if you continue going in this way, it basically will fan out, and you will be able to find out step by step what are the corresponding probabilities and the prices. Now, you will be thinking that if this is the binomial tree, can we make a multinomial one? Can we make a 3-step process? Answer is very simply yes. How do you do that? So, consider that, let me erase this. So, consider you have a 3-step process. So, this is the grid diagram which I am drawing again. Consider you are here. If it is 3-step process, 1 step up, 1 step constant, 1 step down. Again 1 step up, 1 step constant, 1 step down. Up, constant, down, up, constant, down. Again it goes up, constant, down, up, constant, down, up, constant, down, up, constant, down, up, constant, down. So, in this case what you are seeing that each step by step as you move, you are able to replicate all the different type of instances from a binomial one as you go into the 3-step process, 4-step process, so on and so forth. So, we are not going to discuss in details, but once you understand the binomial one, things would be much more easier to understand how the problems can be solved. Let the portfolio consist of a long position in a 1-step binomial one process. A long position is delta shares. We have already found out that delta would be 0.25 considering the price increase and decrease. Now, we are drawing, rather than using the prices of 18, 22, 20, we are using a very simple concept of variables or the symbols. We would not use any numeric values now. So, considering a long position in delta shares at a stock price of S0 initially, and we have a short position in one option, a price of F. So, option I am trying to denote by not by P or S, because why? In order to not make things confusing, because we are using the symbol P for the probability, hence we are not going to use the P and C as we used earlier for the put and a call option. We find the value of delta which would make the portfolio riskless. We have seen it in a very simple numerical example in the last slide, but we will again continue it in order to make it much more general. For upward price movement where probability is U is greater than 1, the price of the stock is, now it has increased, so it obviously it will increase by some probability, hence it will be S0 into U where U is greater than 1. Payoff from this option is F0, hence the value of the option would be exercised and the value of the actual portfolio would be S0 is the price initially, U is the actual percentage of increase of the spot, and delta is the number of shares. So, this is the overall increase in the share price, and this is basically the payoff from the option. That means, the option has been exercised. For the downward movement, the price of the stock was initially S0, it will now fall down. So, D is less than 1, and the payoff from the option is basically FD. FD I am trying considering that if it is exercised, not exercised. In the initial case, exercise and not exercise we are considering in a very simple way, that if somebody exercises, then the value of the profit and loss would be only the upfront price paid. If it is being exercised, obviously upfront price plus whether the person makes a loss or a profit would come into the action. So, we should remember it very explicitly. In one case, if it is not exercised, the profit and loss is only the upfront price payment, and if it is exercised, it will be upfront price payment plus the profit and loss which is being made. That is why it is being denoted by F0 and FD. So, U means upward trend and D means downward trend for a 2-step process or a binomial tree. So, the payoff from the option is basically FD, hence the overall value of the portfolio is given. So, if you want to find out the value of delta, equate both of them and find out delta, considering that S0 is the spot price as today, U and D are the percentage increase and decrease, and F suffix U and F suffix D are basically the payoff happening for the case of an upward trend in the price and lower trend in the prices of that particular stock. So, now riskless means there is no arbitrage, nobody is going to make an extra profit, nobody is going to make an extra loss. So, once you equate these values, increase in the value of the stock, this is the option, decrease in the value of the stock, this is the option, hence once you equate, this is the equation. This is the same value how we found out 0.25. So, also if the risk free interest rate is R, then we can find out using, so now remember one thing, this upward trend and then downward trend which you have noted down here, these are being utilized in such a way that risk free interest rate is going to come to the picture. Also if the risk free interest rate is R, then we must have, so this would basically be the increase in the price, we are not multiplying with increase and decrease, this is the value of basically the forward which was there as of time t is equal to 0. Once we equate that, and this is what, this was the price which would happen later on, because S0 into u into delta is the price increase, and this is the value of the option. So, this would be basically multiplied by e to the power minus RT to bring out the price as of today. So, hence if f is given, you can find out the f value, which means that is the total value of the options, which would be as at time t is equal to 0, such that the overall profit and loss or the overall hedging is done in such a way, this is basically neither profit nor loss for both the person who has bought that option or sold that option. So, now we will consider very simply the risk neutral valuation. So, if you intuitively think that this is the time scale t is equal to 0, t is equal to t, when you have basically S0 as the price and ST as the price and the strike price is decided, we should decide in such a way that any increase and decrease in the price of the option has been compensated by the risk free interest rate. In what sense? So, if I have gone for a call option or if I am going for a put option, obviously my counter movement would be what? Either I go to the bank and deposit money or go to the bank and withdraw money, depending on which position I am going to play as the time expires. So, if I am not going to make any profit and loss, it should definitely mean the amount of money which I have deposited in the bank and when I draw out should exactly match the price of that particular stock or particular position I am in, or else it would mean that if I am going to sell it and initially the money which I have used was basically to buy the option, it should happen in such a way that when once I close my position in the option, I get some money, utilize that money and go to the bank and return to the bank the overall principal amount plus the interest rate, which should be in such a way that neither the bank amount of money which I have drawn and basically or basically I have deposited, and when I close my position from the bank and when I close my position of the option, they should exactly be balanced such that there is no arbitrage or there is no extraordinary profit being made by any other party who is going either for a put option or a call option. So, in this case it should mean that technically if you remember x or k value which you had was this s, this is s. So, this should exactly match the value, expected value of the price such that any fluctuation of the price which is there, if we try to basically simulate it infinite number of times, then the expected value ST should exactly match this such that the risk neutral valuation is there such that it is exactly matching the concept of the arbitrage, no arbitrage positions which persons are going to take, such that neither a person who is going in a long position, neither a person who is going in a short position is going to make an extraordinary profit. So, consider stock price is currently at 40, it is known that the end of 1 month it will be either 42 or 43. So, these are the increase in the price and decrease in the price. The risk free interest rate is given as 8% which is continuous compounding. What is the value of 1 month call option? Option with the strike price of 39. So, this is 39 is basically the x and k, and you can find out the value of the call options as that is basically risk free interest rate being taken into the condition of 8% as that the risk valuation which is being done for both the call and the put option should be such that is risk neutral for to both the parties. So, you use this concept, price is increasing, price is decreasing, you have an option where FU is the value of the option, FD is the value of the option, plus and minus depending when it is a call and a put. The price increase would be S0 into U, price decrease would be S into D. You utilize combination of this is the portfolio, combination of this portfolio such that if they are equated such that both on an upward trend and downward trend price fluctuation is such that neither makes a profit nor makes a loss. So, they should be equated. The moment you equate it, you can find out the value of delta. So, there is a delta value here also, that is the number of stocks which you buy. So, you find out the value of delta, that will give you the risk neutral position based on which neither a person is going to make a profit or a loss. So, there are try to understand what is no arbitrage, risk neutral valuation approach which is being done and valuation of a European option. But remember one thing, so we are always going to consider the European option based on the fact that a time to maturity is fixed for us. If you remember in the same way when you compared the forward and the futures, we consider one of them where the time to maturity was fixed and based on that we basically found out the prices. In the same way we will consider the European option, and once the prices are found out, we will try to combine with a similar type of American option which is there, such the price fluctuations which you are trying to get on the European option would give you some knowledge about the price fluctuations for the American options also. So, now we will go to the next topic, we will cover and discuss about Markov. So, this topic we will try to basically keep it very simple. We will consider the Markov property, the continuous time stochastic process, the Ito's lemma, Wiener process based on which the Black-Scholes models are done. We will cover and discuss very simply the log normal property of stock prices, the distribution of rate of returns, the concept of volatility and the concept of derivation of the Black-Scholes model in a very simple manner, and basically then go into, once we consider the overall loop of closing the options, we will solve very few simple problems in the domain of portfolio analysis, and then go into the different risk valuations and how actually these options and derivatives are used in a big way in order to mitigate the overall risk. So, Markov property that is basically a type of stochastic process, Markov chain, Markov property, whatever you are discussing, is a process where only the present value of the variable is relevant for predicting the future. So, what we are trying to do is that whatever the price, whatever the value of that particular variable is of today, would basically have an implication what would be the price day after tomorrow, or one step down the line or two steps down the line. So, if you are saying that price of today is going to affect the price of tomorrow only, then it is basically a simple one step process. We are saying the prices of today is plus the price of tomorrow will affect the price of day after tomorrow. So, obviously, it is two step process in the sense that the day after tomorrow prices is being affected by t minus 1 and t minus 2, where t minus 1 2 is of today, t minus 1 is for tomorrow, and t value is basically for the day after tomorrow price. So, obviously, you can basically formulate different type of stochastic process depending on the order or the step of the process, but we will very simply consider the one step process. So, we will consider this combinations of the movement of the stock prices in two different spheres. One is basically discrete time discrete variable process, then you will have the discrete time continuous variable process, and we will have the continuous time discrete variable process, and the last one would be the continuous time continuous variable process. So, remember the time factor is the time factor which we are considering, and the variable would be basically the x or the y variable we are trying to consider. So, generally if we have the discrete time, then t can be basically 1, 2, 3, 4, so on and so forth, and discrete variable would be, say for example, x minus 1, x plus 1, and so on and so forth. Similarly, the discrete case comes here, while in the continuous case x would be basically in some domain of, say for example, 0, 1, or say for example, it will have a certain probability function f of x. We are not going to go into the details. In the discrete time, as mentioned, it will be 1, 2, 3, 4, and so on and forth. In the continuous case, it will be t is basically between a time scale of 0 to infinity, or say for example 0 to 30 seconds, so on and so forth, depending on how the problems are being analyzed. We can use any of the four types of stochastic process to model the stock prices, but the continuous type continuous variable process proves the most useful one and easy for us to understand in order to basically model the stock prices. In a Markov process, future movement in a variable depend only where we are, not the history how we have reached there. We assume that the stock prices follow a simple Markov process in the sense that, as I mentioned, it is a one step process or two step process. We will consider very simply is of first order or one step process in the sense that whatever the prices is of today has all the informations, all the prices which have happened in the past, and all things are subsumed in the prices of yesterday, which means if it is a 12th of July 2015, we will consider all the informations of the stock prices are available on 11th in July 2015. Again, if you go one step backwards, whatever the prices are there for 11th of July 2050, it basically subsumed in the prices of 10th of July 2050. In case we consider that on 12th of July 2050, all the information is subsumed on 2 days prices, 11th of July 2015 and 10th of July 2015, we will say basically is basically a second order process. Similarly, we could have one for a third order process, fourth order process, so on and so forth. We will consider very simply is the first order process with repetition I am saying, and we will also consider that the variable which we considered, that means that x variable is only in one dimension. We are not going to consider on a 2-dimension process or a 3-dimension process, because stock prices is priced only along the y axis or only and time would be on the x axis. So, having said that, I will basically now end in this class and again start in the next day, again rehash or recapitulate whatever we understand my Markov process. I would be repeating that because in order to make you understand in a much better way, and I will urge the students to at least to understand and read the book of John Searle or whatever other references I have given. And once you and read this in a very simple manner, again I will start the Markov process, how the Markov process is used in the Ito's lemma and the Wiener process, and how we are able to derive in a very simple conceptual way the Black-Scholes model. Thank you very much. We will consider all these points in the next class.